Now let's look at this all notebook for the binomial distribution. Corporation X is buying 150 computers from Dell, and it is known that the motherboard used in the computers have the probability of 0.12 of having some certain defect. So here let's set the sample size n to 150 and the probability of having defect to 0.12. Question A, what is the probability that 10 computers will have the defect? So this basically about using the DBI norm, right, for density. So putting the numbers in, here we have 10 for 10 computers. Actually here we should put in n instead of 150 to be consistent. But you can have 150 directly in here also. And the probability of 0.12 where we should have p, but we can also have 0.12 directly. So this probability gives us a result for the probability that 10 computers have the defect. Question B, what is the probability that no more than 25 computers will have the defect? So this is about using PBI norm, which is the probability P of X less than or equal to 25. So you put in all the numbers, right? 25 for X, and for sample size, and P for the probability. And here we are looking at the lower tail. So lower tail is equal to true, or we just don't write anything there, right? Lower tail equal to true is the default setting. This gives us this result about 0.96 something. Question C, what is the probability that fewer than 25 but at least 20 computers will have the defect? This actually is the sum of probability of X equal to 20, probability of X equal to 21, etc. up to the probability of X equal to 25. So you can use the DBI norm function for each value of X: 20, 21, 22, 23, 24, and 25, which give about 0.3 something. This can be done faster using the PBI norm function. So here we take the probability of X less than or equal to 25 and minus the probability of X less than or equal to 19. So those are two PBI norm functions, right? And which gives the same result. How many computers does corporation X expect to have this defect? This actually is the mean E of X, or the sample size times the probability, which is 18. What is the standard deviation of the number of computers that have this defect? Simply calculate the standard deviation following this formula. We get the result. Question F, corporation X is reconsidering their decision to purchase the computers. They only want to make the purchase if the probability of having more than 22 computers with a defect is less than 0.2. And the question is, will the purchase be made? This needs to calculate 1 minus probability of x less than or equal to 22. So it gives 0.13, which is actually less than 0.2. So you know if the purchase is going to be made. And suppose that you are in charge of purchasing the computer and you want to assure the president that this is a good purchase. You're going to tell, I'm at least 90% sure that there will be at most K effective motherboards. So the lower K is, the better it is. So what is the lowest value of K that you can make this claim for? This needs you to use the QBI norm function. So here you put in 0.9 and n, which is sample size, and p, the probability, and the little tail is now true. It gives you 23. And note that low tail is by default true. So here we can see that k equal to 23 is the lowest value that you can make this claim for.